Okay, so welcome to the data analysis course. Today we're going to get started with the first topic, descriptive statistics. In descriptive statistics, we're going to cover tables, plots, and in our next session, we will go over some metrics to capture and to analyze the behavior, the trends in our data. But today we're going to just focus on tables and plots. So in general, I just want to make a quick introduction of descriptive statistics and why in general statistics it's an important topic. So as I mentioned before, so far the courses that you have taken, math, physics, chemistry, all those courses, the main focus it's on data where every single value is known. All the parameters are known. So that we don't have uncertainty on those processes. However, in real life, guys, you will experience variability in every single application. Even in your daily life, when you go to a restaurant, for example, I want you to think of your favorite restaurant. Which is your favorite restaurant here in Barranquilla? So please mention which is the best restaurant, uh, at least for you, the restaurant that you prefer the most, where you really enjoy every single meal every time you go there. So which restaurant, guys, do you like? So please at least write them down using the chat, or you can anytime just activate, turn on your mic, and just share with the other students. So let me see if someone is sharing. No one? No one, guys? Which is the restaurant that you prefer the most?
The McDonald's teacher.
McDonald's, for example. McDonald's, for example. So do you think that every time you go to McDonald's, do you get, I mean, the food, the taste of the food is the same? Or it changes a little bit? Or even not just the taste of the food, but let's say about the service. Do you think that the service it's always the same? And I would say that in any restaurant that you go, this even the service and the taste of the food it changes. It's not the same, right? That means that that's an example of a process that has variability. That's a process that has variability. You don't get exactly the same service. You don't get exactly the same dish every single time you go to those places. Topping burger, for example, Lina suggested, same thing. If you go to Topping Burger or McDonald's, as someone else said, the taste of the food, the service, the waiting time, it's not the same always. So that's an example of a process that has variability.
Sorry, Professor, we can see your screen.
Okay, I don't know why stop. So let me just make sure that it's sharing again. Okay, what about now?
Yes, yes. All right, good.
Okay, it's working. Okay, so as I was saying, when you go to a restaurant, the service, the waiting time is different. So even if you have a car or a motorcycle, when you fill the tank, I'm pretty sure that the consumption of gallons changes. I mean, the number of kilometers that you can ride your bike or drive your car will change depending of different situations. Like it depends on the traffic. It depends if you are going, for example, to Santa Marta, Cartagena, or if you are here in the city. So the number of miles or kilometers that you cover per gallon, it changes. It's not the same. So it has variability. You don't get always the same number. So in some cases, like in math and physics, you assume that everything is deterministic While in real life, almost every single process, the outcome is unknown. You don't have full certainty on which is going to be the exact value of the outcome. However, you can at least get an idea of like what are the possibilities. So, for example, if you are rolling a die, you don't know which number you're gonna get for sure in the next round, but at least you know that the possibilities are the number 1, 2, 3, 4, 5, 6, right? Those are the six numbers you can get when you roll a die. So even though you don't know the exact value that you're gonna get, at least you have an idea of which are the possible outcomes. So these are the reasons why statistics is important, because it allows us to understand processes where we have variability, where we have uncertainty. And that's pretty much in every single process that we face, either in companies or in our normal lives. Now, why it's important that analysis in general? There are multiple reasons, guys. First, you require the interpretation of quantitative information every time you're reading a book, you're reading a newspaper, even when you're watching a TV. It's common that you see different plots, different tables. Nowadays, that we're suffering the COVID situation, the virus, so every single news is showing us different plots, like number of new cases, number of deaths per day. So the way in which that information is presented to us, that's through descriptive statistics. Like they are using metrics, they are using plots, they're using tables to summarize data and to convey some insight so people can get an idea on how good or how bad is the situation right now. Uh, in your careers in engineering, you will need to use statistics every time you're going to collect data. For example, if you're going to perform an experiment, I'm pretty sure that in mechanical engineering, civil engineering, you're required to perform several experiments, maybe to check or test a material, for example. So in order to evaluate whether that material satisfies, or let's say that it kind of like it satisfies a specific standard, so you need to perform some experiments, and in those cases statistics are required to make sure that the material indeed satisfies the required conditions. In industry and academia, every time we want to generalize some concept, we need inferential statistics to be able to get to conclusions. So statistics is a key element, a key concept in our daily lives. And as professionals, you require the understanding of the three branches of statistics: descriptive statistics, inferential, and predictive statistics. So the example that I just mentioned about COVID-19, you have seen plenty of applications of descriptive statistics, like how data is summarized. But nowadays, it's more common that we see some examples of predictive statistics. So let's say in healthcare, doctors in some countries, they are using predictive models to check or to predict whether a patient has or not a specific disease. So there are some models that are trained to predict whether someone has a specific disease and which are the variables that are relevant or significant in order to make that prediction. Banks, for example, they use predictive statistics when they are analyzing the transactions. So every time you pay something with your card, either debit or credit card, that transaction is analyzed. The bank is able to tell whether that transaction it's an okay transaction, a normal transaction, or on the other hand, if it's a fraud. So I want to ask you guys: have you ever, maybe you or your parents, I don't know, have received like a call from the bank to confirm whether you make a transaction? Have you had that situation before? Let's say that you buy something unusual. Maybe you buy a computer, or even if sometimes you buy like from a web page, like that is not located here in Colombia. Maybe it's something in the US or even in China. So have you received a call or an email or a text message from your bank to confirm whether that transaction was made by you? Andrea saying that she has experienced that with international shopping. Yeah, that's true. Especially if you buy something online, maybe you buy something from Amazon, or if you buy it from AliExpress in China, you get your bank will send you like an alert to confirm whether the transaction is okay or not, because they are using predictive models to confirm, or at least to predict, if each transaction is okay, it's a normal transaction, or if it's fraud. That's a classification problem. Uh, Other examples include, for example, when you want to buy a house, there are models to predict the price of a house, given some features of the house, like how big is the house, the number of rooms, number of parking spaces, like how close are shopping malls or universities or hospitals from that house. So there are different variables that may have an impact in the price of the house. So it is possible to create a model that will make that prediction. Not just with houses, same thing applies to cars, cell phones, laptops, you name it. So predictive models are getting more popular by the day, and like every single time that you are watching the news, you will see some applications. Actually, I think that was yesterday or maybe a couple of days ago. I don't recall well. I don't know if you saw the news. I think it was in Spain. I'm not sure, but they were testing an algorithm that was able to verify if someone had a mask on the face or not, because you know that now with the COVID-19, it's important that everyone complies with the protocols. So they were trying to test this algorithm, like install the algorithm in a camera, so it was possible to check in real time if people were conveying with the mandatory regulation of wearing masks every time, to avoid the spread of the virus. So that was a predictive model right there that was classifying whether someone had the mask on or not. So that's another example of predictive models. You will find in the application, guys, different types of models. Some are classification models, others are regression models. I want you to please find the difference between classification and regression models. Those are like the most popular models that you will see, but there are other models such as clustering, association rules, even some machine learning, but the most reinforcement learning. That's what I meant. Those are the most, but the most popular are regression and classification models in the predictive branch. The last example that I want to provide about classification models, it's when you get an email. When you get an email, the email service that you have, it's able to classify that email that you're getting as a spam, or if that mail comes from someone that is a friend of you, a family member, then it will go right into your inbox. But if, let's say, maybe that email has some like words that are kind of like a flags, like red flags, let's say that it says money, lottery, things like that, maybe that email is going to be classified as a spam instead of a normal email. So these are examples of predictive models working in our daily lives. Every time you use Facebook or Instagram, when you upload a picture with a friend or with a group of friends or family members, you will get suggestions. Like who are the other people in the photo with you. So that's a predictive model right there that is suggesting or it's identifying who else is with you in the picture that you just uploaded. So again, that's a predictive model And in general, guys, we're kind of like getting used to experience those predictive models in our daily lives. So as engineers, you need to know the basics of statistics so you are able to develop these type of models, or at least understand how they work. Guys, please feel free to ask me at any point. If you have any question, feel free to you can write it. You can like send me a question through the chat, or we can just you can just activate your microphone. All right. So that was like an introduction. Now I just want to mention some important, some key definitions. The first one in statistics is population. What is a population? In general, when you want to analyze a process, we mention the population as all the collection of objects, individuals, or animals that we want to study. So, for example, if I want to study the weight, the average weight of the students at Uninorte, so the population will be all the students at Uninorte. Every single student that we have here in Uninorte, either undergrads or graduate students. So that will be the population. But sometimes it's difficult to access to the whole population in a study. So instead of like contacting every single student at Uninorte, one option is that you are going to collect a sample. So what is a sample? A sample is a subgroup, it's a smaller group of the population. So why we need to collect samples? Because in real life, in most of the cases, it's impossible to access to every single individual in the population. So that's normal, guys. For example, when we are in elections, like political elections, like presidential elections, it is impossible for those companies to call every single Colombian citizen that is 18 or higher and ask them like who's their favorite candidate. That's just impossible. So what they do is that they collect a sample. So, but the way they collect that sample, of course, it has some statistical background. It's not like only a random selection. They have some guidelines or some methodologies to be able that they get a good sample. But that sample, it's a representative sample from the whole population, so they can make an inference about the population using the sample. A key concept here, or the third one, it's a parameter. So what is a parameter? A parameter is just a characteristic that we can measure from the population. So for example, as I mentioned before, if we're studying the average weight of the students at Uninorte, then if we are able to measure the weight of every single student, that will be the parameter, because I'm using every single student. But as I said, that's almost impossible. So if we get only access to, let's say, 100 students or 1,000 students, then that's a sample. So the way we call that measurement, I mean, the average weight of the sample is not a parameter. That is called an statistic. We will use these two concepts later, parameter and statistic, when we are in the fourth unit, in the fourth, fifth, and sixth unit. We are going to use these ideas of sample and parameter. But now let me show you a better explanation of these three concepts. So first, we want to know about these people. So this is the population, this is the whole group, the complete set. That's what we call the population. And if we measure something, some property from those individuals, then that's what we call a parameter. The parameter, again, we get the parameter using the whole population. But if we get a sample, a subset, so it's only a small group from the initial set, then if we measure the property using the sample, then that's not a parameter. That's what we call a statistic. And of course, the notation will change. So the average value it's mu for the parameter, but for the statistic, it's called x bar. Again, in chapters 4, 5, and 6, we will use this notation of mu and x bar when we get to that point. But it is important that you know the difference when something is a parameter and when something is a statistic. So again, it's a parameter when you're using the whole population, and it's a statistic when we are using a sample. So these are the branches of a statistic. The first one is descriptive statistic. That's the name of this unit, descriptive statistic. So what is the purpose of the descriptive statistic? It's just to summarize data. Summarize data. That means that if you wanna, let's say that we're given some data, like a big table. I don't know, maybe a big table will be like 10,000 rows or more, like 100,000 rows and several columns. So it is impossible for us as human beings to analyze that information just by looking at, like 100,000 rows. That is just impossible. So we need to summarize that data. So what are the tools that we have? So the options are, you can use tables. A table will summarize the data. You can use plots, some histograms, bar charts, pie charts, any other possible plot. So you can use that, or we can use some metrics like the average value, standard deviation, median, the mode. Some key statistics are useful when you want to summarize data. So descriptive statistics, it's about representing our data in a meaningful way. So it's like translate our data into something from where we can understand, or at least get a better analysis of what's going on with our data. So that's descriptive statistics. Again, summarize everything in tables, plots, or metrics. Those are like the three main tools that we will cover in the first unit. Then we talk about inferential statistics. So what is inferential statistics is very important in engineering. For example, when you are performing some quality control in a company, and you want to check whether a raw material or a product if a product has good quality, you need to use inferential statistics. So why we call it inferential statistics is because using a sample, we're going to try to make an inference, or we're going to try to generalize an idea about the whole population. So that's what we call it, inferential statistics. So it's a branch of statistics that uses samples to get or to arrive to conclusions. And lastly, the third branch is predictive. It's when, as the name implies, is when you want to predict a variable. I already provided some examples at the beginning of the session about the predictive statistics. In the last unit, unit 7, when we get to the linear regression models, we're gonna talk about predictive statistics. Now, when we're given data, one of the first steps that we need to perform is to understand the variables that we're given. So there are like two big categories of variables. So one is quantitative variables, and the other one qualitative variables. So quantitative means that it has a numerical value. Now, in the quantitative variables, there are two like big groups: continuous variables and discrete variables. So what's the difference between continuous and discrete? So I want to ask you that, guys. What's the difference between continuous and discrete variables? Can you please provide an example? What's the difference when you use one or the other? So how can you distinguish between a continuous variable and a random variable? So please, again, guys, feel free you can talk freely, or you just can just send something, send a message to the chat. I will read it for you. No one, I'm waiting.
What is the question? teacher? Again?
The question is, what's the difference? I mean, what's the difference between a continuous and discrete variables? The difference between continuous and discrete variables.
Well, I think that continuous variable is when, like example, takes whatever number, I mean, a set of possible values for a random, I don't know, experiment on or whatever that the variable has taken in that in a descriptive, uh, taken only like mm, one possible number or whatever.
Discrete is not just one number. Discrete is not just one number. I mean, the main difference between continuous and discrete is that the continuous it might have decimals, and in general, you will have a continuous variable when when the number comes from a measurement. For example, the height, the weight, those are continuous variables. You are measuring something. You are measuring something. It might have decimals, right? But if you're counting, like let's say the number of students that are connected right now in this meeting, that's a discrete variable because it's a counting process. We're using integer numbers to describe the number of students that are connected in the session. So far there are 33 students here. So yes, as Lina just said, discrete variables are countables, yes. And examples that are provided by Randy are okay too. So number of people in general that is discrete, yes. Number of students connected here, number of students or number of people that are right now in a supermarket, that's a discrete variable. But if we start measuring something, then that would be a continuous variable. All right. Now that was quantitative variables. Now in the case of qualitative variables, those are not numerical variables. So they are basically attributes or characteristics that can be classified based on a specific attribute. So examples, imagine that we're analyzing the color of a car. So you have black cars, gray, blue, yellow. So that's an attribute. It's not a measurement. It's not a counting process. It's just an observation and it's a property. It's an attribute of the car. So those are qualitative variables. If you talk about gender, male, female, for example, those are attributes. If you talk about ethnicity, if you talk about, for example, for example, the country where you're from. So the country, it's an attribute too. I can expand more on examples of attributes. If you're analyzing, for example, the education level of someone, that's an attribute too. Now we have some subdivisions of the data. In qualitative data, we have nominal and ordinal variables. So what are examples, or what are nominal? Nominal means that the values have no quantitative value. That means that you cannot arrange them. You cannot arrange them. For example, if I ask you, which languages do you speak? So if you speak Spanish, English, French, or Chinese, it doesn't matter. I mean, that attribute of the languages that you speak, you cannot sort them. You cannot arrange them. You cannot arrange them from the highest value to the lowest value. It doesn't make sense. Same thing with the color or gender. In that case, that variable, it doesn't make sense and order. But on the other hand, if you're talking about ordinal variables, the order has meaning here. So for example, if you talk about education level, you can arrange the education level. So you can say high school, undergrad, and graduate studies. So it has an order. It has an order. If you go to a restaurant and you're gonna evaluate the service, like excellent service, good service, regular service, or poor quality service. So you can arrange them. It makes sense to arrange them. It goes from a lowest to a highest value. So that's the difference between nominal and ordinal. All right, guys, before I proceed, who can provide an example of another example of nominal variable and an example of ordinal variable? Again, both are qualitative, but the difference is that one can be arranged and the other one cannot. So who can provide an example of nominal and a nominal variable and an ordinal variable, different from the examples that we mentioned here? Who can provide an example? You could, again, guys, use the chat or feel free to talk.
I think, hello teacher, I think that the other example is of the nominal is a color of the cars, no?
Yes, of course, the color of the cars, that will be a nominal variable. What else? I mean, something different than color. Who can provide another example?
Maybe gender.
Gender, of course. And what about ordinal? Ordinal variables. An example.
Socioeconomic, like for example, here in Barranquilla, estrato 1, 2, 3, 4, etc.
Yes, yes, that's true. That's not a numerical variable. Even though we use numbers like, as you said, 1, 2, 3, 4, 5, 6, actually that's not a measurement. That's not a counting process. That was just an attribute that was defined according to the location, maybe of the neighborhood. But other than that,
High
it's not a
school.
measurement. So that's a qualitative variable. So that's an example of ordinal. What else? I think someone was trying to mention an example. Okay, I think, okay, Pedro. Okay, I have several here. Lina said nominal blood type. So there is no order, that's true. So you can be, what are the blood types? Like O positive, like A. I don't recall all of them. But that's a good example, yes. It doesn't make sense to arrange them. And then satisfaction rating, yes, that's an attribute too. Then we have Pedro, the clothing brand, that's nominal, yes, it doesn't, you cannot arrange them. And the grade, the school, well, the grade, that's like the position. Okay, yes, like a ranking. When there is a ranking of schools, that's true. That's true. That like first position, second position. So that might be it depends if they use like a very formal tool, but most likely it's more like an observation. And Natalia is suggesting an ordinal can be our satisfaction with some services. That's true. That's true. Because you can arrange the satisfaction level. Okay, I think it's clear. I think it's clear. The these two types of qualitative data. Now let's check here quantitative data. The quantitative data, we have two types. This is like a theoretical, a very theoretical classification. This part, I mean, the most popular classification that you will see, it's continuous and discrete, but these two are more like theoretical. Interval data or ratio data. So what is the difference between these two variables, interval data and ratio data? In the ratio data, there is an absolute zero. I mean, it's in a numerical value, it's a quantitative data that has an absolute zero. For example, imagine that you have your wallet and your wallet is empty right now. So the amount of money in your wallet is zero. That's an absolute value. I mean, if your wallet is empty, then the amount of money that you have in your wallet is zero. So that zero means that you have no money at all. It's the complete absence of money. So that's ratio data, where the zero is an absolute value. For example, if weight is zero, it means that it doesn't have a weight. Now, in the interval data, it's when the zero doesn't mean the absence of the property. For example, if we're talking about the temperature, the room temperature, if I say that the room temperature right now is 0 Celsius degrees, does that mean that there is no temperature in the room? What is the mean of zero in a room? If the room temperature is 0 Celsius degrees, what is the meaning of that?
Is a simple value
So
because it's other values.
but
For
my question,
example, one greatest.
so it can be, yeah, 1 - 1. But my question is, if the room temperature is 0, does that mean that we don't have a temperature in the room?
No, it doesn't mean that there's no temperature. It just means that it's a ordinal variable, and it's saying that the temperature is like in a scale where is positive and negative temperatures values. So it doesn't mean that there is no temperature. It's just like a scale, and we can
Right.
say that that is an ordinal variable, I think.
Yeah, that's correct. That's correct. I mean, it's just on a scale where the zero is not an absolute value. It's not an absolute zero. In the ratio data, the zero represents the absence of the property. So if I say that the room temperature is
Teacher,
Professor, I think you're mute.